Hi, welcome to 2-6. We're doing equivalent expressions with technology. That means making use of a calculator with CAS. CAS stands for Computer Algebra System, and it's a method by which you can put in an expression and do things to manipulate it using algebraic steps that would allow you to compare and see whether something is equivalent, what we were doing last time. So we'll be using that this time to try to figure out what's going to be, whether two expressions are the same or not. So let's take a look at a few things. In this lesson, we've got our first example is asking you to find a formula for the area of the deck by splitting up the deck into four rectangles. Well, if you look at this image here on page 98, you'll see that we've got length and width of the deck, of the edges of the deck, and then X represents the actual width of the deck itself, so the actual spacing of it, and that looks like it's the same all the way around. Now if we're going to split this up into triangles, or excuse me, rectangles, you're going to have to look at how you're going to split it, making sure you avoid counting anything twice. If you have overlap, you have to try to account for that. So you should go ahead and take a crack at this. I'm going to pause this for just a second, and while I do that, you should pause it too, and we'll come back in a second to see what happens. Okay, now that we're back, you should have taken a crack at it, tried it yourself, and now let's look at a couple of solutions. We've got Sonia and Roxy. They both found formulas for the deck. We got Sonia's method, and she broke it into four smaller rectangles. We can see that she had an area here that's x wide and x wide, and we can see the area 2 is simply L minus those two x's. The reason she subtracted that was because that length had already been taken into account for area 1 and 3. We can see how this width, the W length, is that entire length, and it took up that spot. So we had to take that away from what was L, whatever L is. So that's her formula. Okay, Roxy's method. She saw the deck as the area of the pool and the deck minus the area of the pool. So she got the entire area, which is W times L, and then she wanted to subtract from it just the area of the pool. So she subtracted the W minus 2x, which is the width of the pool, times L minus 2x, which is the length of the pool. So she subtracted out the area. So we've got two methods. You may have had a different method. If you want, you can compare yours to these. We're going to take a look at how can you use a CAS to answer the question, are these equivalent? This is really exactly the same as if we were to do the algebra and manipulate these equations to see if we could simplify them to something where we can see that indeed they are the same expression. We're going to do this now with some technology. So we're going to use the CAS to test for equivalence. If you don't have a CAS, you can do this algebraically. You don't need a calculator to do it. If you're asked to do it using a CAS and you do not have one, then do it by hand. Do it manually. If you have the CAS, that's great. You can go ahead and use that to complete the task. I'm going to show you now how to do that. Give me a moment to get that set up, and we'll get on with this. Okay, we're going to take a look here at Activity 1 for 2-6, where we use the CAS. If you don't have one, you might want to borrow one. Come see me if you'd like to borrow mine. It is only to be borrowed and used in the classroom, but you're certainly welcome to make use of it so you can see how this type of thing would work. So here we want to do is compare the two expressions that Roxy and Sonia came up with and see whether they are equivalent expressions. So the first thing we want to do is in step 1 we'll look at Sonia's expression. Step 2 we'll take a look at Roxy's, and then we'll be able to look at the results and compare the two of them. Okay, here we've got our emulator again for the CAS calculator. We want to go to the calculate screen, so I could either touch the pad and go to A, or I could just hit A here on one of the buttons, and I find often just hitting the letter is easiest. So I'm going to click on A. I'm into the calculator function. I want to choose the expand command. The expand command is basically telling the calculator to use the distributive property to try to simplify the expression. So we're going to go ahead to the catalog. That's a little book thing. You can see it's in red right now on the keypad. It's on the right side. It's red. I got the little cursor on it. We click on that. It opens up this list of various commands available, and I see that I've got expand selected. I have many other things that are in here that could be used. In this case, all I really want is expand. So I'm going to just hit enter and select that, and so now I've got expand selected. You can see it's got a parentheses, and that's basically saying expand whatever's in the parentheses. So we're going to enter the first expression, which is Sonia's, and that was W. There's no dot in between the W and X, but we need to do that with the calculator. We need to tell it that it's multiplication. So W times X. Then we are going to add X plus X, and that's going to be X times, again we have to put in the multiplication sign, open the parentheses, L minus 2 times X. So there we've got the first part of the expression, which is W times X plus X times L minus 2 times X. We need to close that parentheses, and we're going to then add to it the plus W times X plus X times L minus 2X. Open parentheses, L minus 2 times X, close parentheses. So I think we've got it. Let's just double check real quick. I've got W times X plus X times L minus 2 times X plus WX times W times X plus X times L minus 2 times X. Okay, so I've got this done, and need to close our parentheses, and we're going to hit enter. And here it's expanded this expression and given us that it's equivalent to 2 times W times X minus 4 times X squared plus 2 times L times X. So that's our first expression. We'll take a look at the next one. Again, we're going to go back to the catalog. Expand's already selected, so we can go ahead and hit enter. And now we're going to input Roxy's expression. And that was W times L. So that was the width times the length minus, and now we need to put this in parentheses, open parentheses, W minus 2X, W minus 2 times x, we have to include that. We close our parentheses. We're going to multiply that times, open parentheses, L minus 2 times x, close parentheses. So this was the one where we took the total area, which included the pool, width times length, and we subtracted from it the width and length of the pool. I need to close out my parentheses, and I've got, let's see, W times L minus W minus 2x times L minus 2 times x. I'm going to enter and expand that, and now we have a chance to compare the two expressions. And here we see we've got 2 times W times x minus 4 times x squared plus 2 times L times x, and indeed the two expressions are equivalent. We've successfully used the CAS to compare two expressions and check for equivalence. Before you turn the page, I want to give you a tip on how to proceed with the next activity. Wait, don't turn the page yet. Hang on, be patient. What you should do on this next one is you should cover the bottom part of the page. Get a sheet of paper, and when you turn the page, basically all you should see is the activity 2 part of the page. That should be it. Alright, now we're taking a look at page 101, but you don't know that because you can't see it. You've covered it up. No peeking. The key with this is to give yourself a chance to try to solve it yourself rather than waiting and looking at the answers, because then you look at it and you go, oh yeah, I know how to do it. Well, no, you know how to read it. That's different from knowing actually how to do it. So let's challenge yourself a little bit and try to do this before you look at the kinds of solutions that are down below. So the first thing you'd want to look at is, it says find 3 expressions equivalent to 2 times a squared plus 4 times b. In each case, use a CAS to verify the equivalence. Again, if you don't have a CAS, do this using algebra. To form equivalent expressions, use the properties you have learned, but in reverse. Instead of trying to make the expression simpler, you need to make it more complicated. There are a lot of approaches to this that you could take, and you want to be able to try that. So go ahead and take a crack at it, see if you can find some expressions. Then once you've done that, begin to lower the page and see if what's being presented is similar to the kind of thing you came up with. It may not be exactly the same. It doesn't mean yours is wrong. It just means may just mean yours is different. The proof of that is when you algebraically compare the expressions to see if they are equivalent, either doing it through the use of properties or doing it with your CAS. Alright, hopefully you've got 3 of them and you're ready to go, but let's take a look at a first one. This is one possible solution, and in this case it's noting that 2 times a squared plus 4 times b could be written where we factor out the common factor, which is 2, and it's 2 times a squared plus 2b. We want to know, is this an equivalent expression? We'll check it with the expand command with the CAS. We can see from the screen that indeed the expand command gives us the same expression. We have one equivalent expression. Now if you've done this and you've done some others, then just let's go ahead and look at what I've got here for expression 2 and expression 3. Or you could look on your own in your book. If you didn't get this one or didn't get any, use this as a clue about what you might do, and then try something else before you move ahead. So go ahead and pause this. Don't look any further in the book. Make an attempt. You want to try to exercise yourself to see if you can get this done. Okay, let's see. We've got a couple other things that have occurred. First one was to just simply multiply the whole thing by a form of 1. 1 doesn't have to be just the number 1. There's a lot of things we know that are equal to 1. and therefore they would work as though you were multiplying by 1. They wouldn't actually change the value of the expression. It just would change how it's being presented. So expression 2 shows us a way to multiply both parts of this expression by 3 over y. So 3 over y over 3 over y is equal to 1. And we multiply that times 2a squared, and then we do that 3 over y over 3 over y over 3 over y times 4b, and we get, again, an equivalent expression. Finally, in expression 2, we're going to apply the identity property of addition and then rearrange the terms. The idea behind this method is to add a form of 0 to the expression. Again, it doesn't change the value, but it looks different. And in this case, what we've done is we've taken 3a squared plus the opposite of 3a squared, which is equal to 0, so we've added nothing to the expression, but we've made it appear a little bit more complicated. So when we go back and we go through this thing, we have a new expression that is 5a squared plus 4b minus 3a squared. We want to know, is that equivalent? We put it into our CAS, and again we find that we have an equivalent expression. Looking at the next assignment, or the next activity, excuse me, is activity 3. And activity 3 asks you to find at least 4 equivalent expressions for each of the following expressions. Try to use more than one property on each expression. See how complicated looking you can make your expression while maintaining equivalence. Use a CAS to verify that your expressions are equivalent. So take a look at these. Try to do them. Make an effort at doing it. Talk to some of your friends. See what they've come up with. Then once you've done this, you might want to check in with me about what kind of solutions you could have gotten and see if they work. The thing that's cool about it is if you use a CAS and you do it correctly, you'll know whether you got it right or not. So make it as complicated as you can. Make it difficult. Try it out on your friends. See if they can think it's equivalent or not. See whether they can use their CAS to make this happen. So have some fun with that. Once you're done with it, then again, your assignment for this lesson 2-6 is to do the covering the ideas and applying the mathematics section. Once you're done with those, remember, turn them in to me. I'll be checking them. You'll be able to take your mastery quiz the next day, and I hope you have good luck with it. Should you have questions, want some help with something, remember to write it up on the board. Give me a chance to take a look at it and prepare either a mini lecture or give me a chance to get together with you to help you work through it. If you're waiting for me, don't delay. Practice the things you can do. Go on to the parts of the assignment you can complete. Maybe even begin reading ahead or double checking your notes. Good luck. I hope to see you on the mastery side of things.